Hello, everybody. I'm Sofia Rivera. I'm the chair of the Radiation Oncology Group of Unicancer, and I would like to present you today our new young group. So the group was initiated in 2014 with the aim of regrouping the efforts of research in radiation oncology in France. It's a multidisciplinary group in which we have radiation oncologists, radiobiologists, physicists, radiation technicians, and politicians, as well as clinical research staff. We have a multidisciplinary board with radiation oncologists and physicists, and of course, Asia Lamrani, who is a representative of Unicancer. Our vision is that radiotherapy optimization and combination of radiotherapy and treatments will improve prognosis and quality of life of patients with cancer. Our ambition is to accelerate the progress in radiation oncology for the benefit of most. And our objective is to facilitate clinical and translational research in radiation oncology. For that, we have launched 5 working groups. The first one works on artificial intelligence, combining topics around radiomics and imaging. Then we have a second working group on radiobiology, focusing mostly on immunoradiotherapy, radiosensitivity, and radiopotentialization on the tumor. We have another working group on new technology and physics developments and innovation. Then we have a working group on quality assurance, safety and security in radiotherapy. And last but not least, we have the PROMS and real-life data group. And this will be presented by Sébastien Guillard and Jean-Baptiste Clavier, together with the work and project they have on real-life data. So our aim in UNITRAD is to conduct changing practice clinical trials and also to homogenize daily practice in radiotherapy to optimize quality and safety for our patients. In order to do that, we integrate radiobiology and radiophysics. We also perform evaluation of new indications of radiotherapy via innovative dose delivery, together with the evaluation of new combinations of drug and radiotherapy. And by drug, I mean systemic treatments such as targeted therapies or immunotherapies, in order to optimize radiotherapy practice. Our group UNITRAD is positioned as a sponsor for clinical trials, and we aim at changing practice studies with primary objectives focusing on radiotherapy, gathering multiple tumor sites, and collaboration at a national level through Unicancer, but through other groups as well, and international collaborations. We have a role of support of the various Unicancer groups with different tumor sites. The idea behind is that in several trials involving radiotherapy, while often the quality of radiotherapy and the specificities of radiotherapy are not completely optimized, and we propose a support regarding methodology and quality assurance in trials involving radiotherapy, even in those trials which are not completely and only focusing on radiotherapy, in order to have robust data and robust quality of radiotherapy in those trials. So it's a technical and strategic expertise that we offer to other groups. We have academic collaboration, and indeed we mostly rely on academic foundings for developing our projects, and these are clinical and translational projects at a national and international level. We start having more and more industry collaboration with big and small farmers, also with artificial intelligence startups, and with various vendors of radiotherapy machines. Our goal is to integrate all these data, and you will see part of it today with the presentation of the real-life data project. So the idea is not only to integrate clinical data with biological data or DICOM data, but also with PROMs and data from the patient, and to be able to integrate all that in order to both monitor the outcomes, the toxicity, the quality of our radiotherapy, but also to build up predictive models for outcome and toxicities. And with that, I will leave the floor to Jean-Baptiste and Sébastien, who will present the project on real-life data. Thank you for your attention.
Thank you, Sophia, for that nice presentation. So, it's my pleasure to introduce you our project of data farming in radiotherapy, built on the daily use of Mosaic. So, what is data farming in radiotherapy? Charles Maillot published a nice article on 2060 on the concept. He sees a cycle divided in 3 steps. The first step is cultivating data sources. Second step is to harvest information. And the first step is to use that data to feed knowledge to improve patient care. So the first step is to cultivate the data. What we see today is that the information of consultations or treatment are based on paper chart or medical letter created by speech recognitions or free text in different software. The important point is all that data are unstructured, so they are very hard to use for science. What we propose is to remove that media and replace them by standardized consultations form based on the Mosaic existing forms. The forms are similar to CRF of clinical trial. It's a compromise between time and comprehensiveness. We created it in order to be user-friendly for daily practice and usable in consultation from 10 to 45 minutes. And the most important point, I will show you an example later. We use the data of the form to create automatically medical reports. So the important points when you start data farming is the dataset. Which dataset are collected through the forms? So we started in 2016 to work on it with 16 radiation oncologists from 8 Unicancer network radiation departments. We divided the patients in 8 anatomical regions and 3 types of consultations: baseline, before treatment, acute for toxicity during treatment, and late for the long-term survey. Finally, we have 39 forms on Mosaic with a dataset of 421 items like weight, pen scale, and a lot of serious scale types. After that, we asked 2 ELECTA consulting services to replicate the form from Strasbourg, where we created it, and to the rotation departments who have forms with us. And since 2017, they gradually integrated the forms in their workflow. And now it's time for Jean-Baptiste Clavier, my colleague, to show you an example.
So I will show you how it's working in the OIS Mosaic. We have the patient chart. Here we have the summary of the medical history of the patient, and there you have the previous consultation data available. So if you start a new consultation, you have this typical report. Here, for the example, I've chosen a breast follow-up consultation, typically 1 or 5 years after the radiation. So here you have the date of the consultation. Then, for example, it's a 5-year consultation. We could ask the question for how does the patient feel, what's the weight, is there any pain in the breast, for example 6, no only first stage painkiller and no constant pain. Here you can put the medication. Here she don't take anything except, for example, an hormonotherapy. Here's the flush. You can see it's in this case it's a CTC AE grade, so you have the grade available. If you know it by heart, you can only type the number. So all the items are possible. No one is mandatory. So if it's not relevant, you can skip the item. And it allows quick consultation. You can keep eye contact with the patient and be regular and ask the question in approximately 10 minutes. Here we arrive to the clinical examination. We can report, for example, radiation dermatitis or edema. When you need, for example, to make some prescription, for example, mammography in 6 months, you can have the prescription here next 6 months. You can have automatically the prescription using the IQ script module from Elekta. Here you can check if the patient have a relapse or not. For example, no relapse, no metastatic, and everything is in the database. And here we can write to a few other doctors. For example, Dr. Beck, general practitioner, and another one. So here the consultation is over, and we can create, for example, the patient need additional treatment from anastrozole. So we can continue anastrozole, and in 1 click, it creates the report and the prescription in this case. So here I have all the prescription and the letter. Yes, all with the summary, all the questions, and everything is done. So you have your report and you have the data.
Thank you, Jean-Baptiste. And so you cannot see on the presentation, but it's very time-sparing activity tools that we are very fond of it. So for our data farming project, we need additional data. We need the ID data, the tumor data, and the radiation data. So we use Mosaic to collect information about the tumor, and we use, of course, Mosaic for the identity and the radiation data. And it leads us to the second step of data farming, is harvesting information. Once again, we call Elekta, and Elekta Consulting Services created an SQL relational database with 428 items with a copy of consultations form, tumor data, and radiation data. And this relational database is on the Mosaic server in the hospital. So it is GDPR proof, and we use it in a second step using the R software. R is a free software you can load on internet, and we use it to create Excel files in a way to answer our clinical question, our clinical challenge, for a very fast use for a radiation oncologist like me, who is not able to use the SQL database. So it works. Last year, we did a check of the data in the multicentric project with 5 anti-cancer centers, and we found in Mosaic more than 50,000 consultations for more than 1,100 patients. So it's a large collection of data in a multicentric way. It leads us to the step 3 of data farming, is to feed knowledge. So as long as we collect data, as you see on that part, we accumulate data to publish them, and we start in the French conferences, French annual conferences, and year after year, you see we publish more and more abstracts at ESTRO and ASTRO. And we have 2 local work for the MD thesis in France. If you want to go further, this is a list of the publications. Some are in French, and some are in English. So, in conclusion, we can use Mosaic for a multicentric and large data farming. We did the last 5 years a first cycle with cultivating, harvesting, and few publications, and our next step is to use a new data set with DICOM-RT and PROMS data. We have project with artificial intelligence on the large database, when we have more classical large multicentric cohorts study. And of course, it is the objective of the video. We are looking for new farmers in other language. We can very easily translate the forms in English, in German, in Italian, in Spanish. So if you are interested and if you want to become a data farmer, you can send me an email with that address. It's time to close this presentation. So I would like to thank our partners, all the anti-cancer centers who believe in that project. And I would like to thank to Mr. Rémi Eugène from Electa Consulting Services. So once again, if you see that video and you are interested to be a data farmer with us, you can send me an email. So thank you for your attention and have a good day.